Hi guys! We are going to take a moment to explain goal number 2 from the thermal energy unit, which is illustrating the flow of thermal energy between two regions at different temperatures. So we talked about in class how thermal energy flows from regions that are at a higher temperature to regions that are at a lower temperature. And these two regions will always transfer heat until they reach what we call thermal equilibrium, or they reach the same temperature. Now, keep in mind that when we talk about this topic, it's always that it's heat flowing, right? So cold does not flow. It's a one-way street. So it's always that the object that is at the higher temperature is going to transfer its heat energy to the object that is at the lower temperature. And also, these objects need to be in contact with one another in order for their particles to interact for that transfer of heat energy to occur from the one that's at the higher temperature to the one that's at the lower temperature. And so part of this goal is being able to illustrate, meaning to demonstrate or show, how heat is transferred between two regions. And so looking at this picture here, we have a wintry scene with our Bitmojis. And if I wanted to illustrate how thermal energy is flowing in this picture, I really want to think about which two objects are in contact with each other that have different temperatures. Because the object that has the higher temperature is going to transfer its heat energy to the one that's at the lower temperature. And so if you look at Mrs. Sarnelli, who has built her igloo fort here and is throwing snowballs at me, she is holding the snowballs, and so you can assume that her body temperature has a higher temperature than the snowball. And so if I wanted to illustrate how thermal energy is flowing, I would draw an arrow from her hand to the snowball because her hand has a higher temperature than the snowball, and so heat energy is going to flow from her hand to the snowball. And with that, we can also assume that her body temperature is at a higher temperature than the air around her or her surroundings. So some heat energy is also going to be transferred from her body to the air around her. Now, if you look at me, who's all bundled up, getting attacked by the snowballs here, heat energy from my body is also going to get transferred to my clothing, right? And so my clothing, as you can see, I'm pretty well insulated here. I'm trying to trap that heat energy from escaping, but some of it will also escape over time to reach that thermal equilibrium. So my body heat energy is also going to transfer to the surroundings as well. Looking at another example of this, instead of a wintry day, we're going to look at the opposite if it were a warm, hot summer day. And for this example, we're going to assume that it is over 100 degrees out. It's just a really hot day. And Mrs. Chronopoulos and I are relaxing during the summertime on the beach with some lemonade. If it is a really hot summer day over 100 degrees, we know that the air temperature is warmer than our body temperature. So we can draw an arrow to illustrate from the air to Mrs. Chronopoulos, showing that energy is moving from the air towards her. We can also assume that the air would give energy to me and my body, so we can draw an arrow from the air towards my body because the air is at a higher temperature and I'm at a lower temperature. Our lemonade would also gain thermal energy. So the air or the table that it's sitting on would provide energy towards our lemonade, meaning that the air particles right around the lemonade will slow down, and the particles within our lemonade, as they gain the thermal energy from the air, will speed up. So this is just another example of how energy is flowing between various regions, once again, always from higher temperatures to areas of lower temperatures. So there you have it. Thank you for watching.